Today we're going to have fun with voltage dividers and op amps. So let's pretend we have a circuit powered by 5 volts because it's powered by a USB port. So let's say, and you saw this in lab, but let's say we need something besides 5 volts, like we need 3 volts or 2.5 volts. How can we make a 2.5 volt voltage rail when we only have 5 volts? The easiest way is to use 2 resistors, like this. Let's call them R1 and R2. So what's V out going to be? It's voltage divider. R2 over R1 plus R2. When R1 and R2 are equal, you get V out equals V in times 1/2. So here we've just made a 2.5 volts. So that's good. What if we want to go and use this? We can connect an LED or something. Well, you know you need to use a current limiting resistor in series with your LED, just so that you don't destroy it with too much current. So we can connect it like that. Now, is this going to work, or is there going to be a problem?
Well, no. Yeah, I mean, sometimes.
But why? I'm going to say this is RL, and that represents the resistance of our series resistor, any wires, and the diode itself. So why doesn't it work? Well, now we have a resistor in parallel with the bottom resistor. So V out is actually going to be V in times R2 in parallel with RL over R2 in parallel with RL plus R1. So you're not actually going to see 2.5 volts, you're going to see something else. And that's the reason why. So how do we solve this problem? Well, one thing about op amps
and operational.
and the ideal op amp is it has Rin equal to infinity.
That thing's operational.
So we can connect it in this way. So if this Rin at this terminal really is infinity, then what's going to happen? Well, we're going to have V out equals V in times R2 in parallel with R infinity over R2 in parallel with infinity plus R1. What's R2 in parallel with infinity? Well, it's 1 over R2 plus 1 over infinity. 1 over infinity is 0. So it's actually, this is equal to 1 over R2 plus 0, which is equal to R2 over 1. So if this truly is ideal, which, you know, it's not going to be too far off, then it's going to work great. This is actually called the voltage follower. Or a buffer. So we can connect a voltage reference made from 2 resistors straight to an op amp. It's going to buffer current from our supply, -5, 5, whatever you have, and then it's going to give you it's going to follow the voltage at the input. So output, you'll see 2.5 volts always. It's going to work great. Okay, so I built the circuit on the breadboard. I'm using 30K resistors, two 30K resistors for the voltage dividers in each case, and just a regular LM358 for the op amp. And you can see, well, this is a 10K series resistor right here. But you can see the LED coming out of the op amp is way brighter than the LED that's not coming out of the buffer. This is at the 5-volt supply. So an interesting thing is that the LED connected to the voltage divider without a buffer, it still lights up. There's a little bit of current flowing, but it's way brighter. So what's going on? Well, the multimeter is connected to this voltage divider, and I'm getting 2.15 volts. Whereas if you connect it to the buffered version coming out of the op amp, I'm seeing 2.50 volts. So yeah, so this circuit is being affected by the load.